Okay, welcome back, everybody. We are going to start a topic of geometry that is very proof intensive. So there's good news and bad news. Today's assignment has only 8 questions on it. So that's the good news. The bad news is that they're all proofs. So these are 2-column proofs that we're going to be doing today. And you got to get good at this. You got to develop some skill at this. This really goes to the heart of geometry, proofs of theorems, and using proofs to prove other things. So the topic of the lesson is Cpctc, and that is just an abbreviation of the following expressions. It stands for corresponding parts of congruent triangles are congruent. So you can see that I've underlined those letters. And so again, we use this as a reason in a proof when we write a 2-column proof. So I got for the lecture today, I've got 2 proofs. One is we're going to just talk through it. And then the second one we're going to do in 2-column format to give you a feel for what the homework is, because the homework are all 2-column format. Okay, look at the drawing there that I have. You see a bunch of triangles. We're given that segment AB is congruent to segment DC. So you see that marked off there with 2 red tick marks. And you're also given that angle ABC is congruent to angle DCB. So those are also marked off with little red arcs there. So what we're trying to do is prove that angle A is congruent to angle D. So you see up here these 2 angles that we're trying to prove those congruent. So what we need to do is develop a strategy. So here's the strategy, and here's how we're going to use that corresponding parts of congruent triangles are congruent statement. We're going to prove 2 triangles congruent. I'm going to highlight them so you can see what we're doing. We're going to prove this triangle. I'm highlighting in yellow. Triangle ABC. We're going to prove that triangle congruent to triangle BCD, which I'll highlight in blue. Just because there's so many triangles there, it's hard to sort them out. I think the color is going to help. So if we can prove that those 2 triangles are congruent, and remember now we have 5 ways to do that, then we're going to say that angle A and angle D are congruent because they're corresponding parts of congruent triangles. And we know that congruent triangles, all the corresponding angles are congruent and all the corresponding sides are congruent. So if we can say those 2 colored triangles are congruent, then we can say that angle A is congruent to angle D by Cpctc, corresponding parts of congruent triangles are congruent. Okay, so we're given some information. We can also mark off what we can deduce. And if you look at the diagram, we can say that segment BC is congruent to itself, and that would be because of reflexive property if you were doing a 2-column proof. Reflexive property. Okay, now look at the 2 colored triangles. You can tell now that triangle ABC is congruent to triangle DCB. In other words, the yellow triangle and the blue triangle are congruent by side angle side, so SAS. So if you were doing a 2-column proof, you'd say triangle ABC is congruent to triangle DCB by SAS. You see the side angle side in there. And then your last statement in your proof, of course, is what you're trying to prove. So you would then say angle A is congruent to angle D because of Cpctc. Once you know those 2 triangles are congruent, the 2 colored ones, then you know that all their corresponding parts are congruent, and so you can say angle A is congruent to angle D. The reason across from that statement would be because of Cpctc, corresponding parts of congruent triangles are congruent. Okay, so we kind of talked our way through that one, but my second and last proof of this lesson is we're actually going to write out all the statements because you really need to have some skill in that. So let's look at the next proof. So you see the diagram there, and so I've already marked off what's given. So we're given that segment EG is congruent to segment DF. Those are marked off with tick marks. And we are also actually parallel, sorry. Well, they're both. They're parallel, and they're also marked off that they are congruent. So segment EG is congruent to segment DF, and segment EG is parallel to segment DF. You can see that by the congruent segments marks and the congruent or the parallel lines marks, arrows. So what we're trying to do is prove that ED, the top side, ED is parallel to GF, the bottom. So again, we're going to have a strategy. We're going to prove, and again, I'll highlight, we're going to prove this triangle, the blue one, is congruent to this other triangle. We're going to prove those two triangles congruent. And then you'll see how it unfolds, but we're going to prove that corresponding angles of those two triangles are congruent. And then we're going to say that these two particular lines are parallel, and we're going to give a statement and a reason for every step. And this is really very similar to what your assignment's going to be like. So pay close attention. All right, so we know in a proof, normally the given is just recopied as a first statement. So we got segment EG, which I have marked here, congruent to segment DF. Those are marked off with the single marks. And we also have given that those same two segments, segment EG is parallel to segment DF. You see those marked off with the two arrowheads. So we write across from that given. Okay, now let's look at our second statement. Angle EGD is congruent to angle FDG. So I'm going to mark those off. So EGD. So this angle right here, angle EGD, is congruent to FDG. So those two angles are congruent. Why? Because if two parallel lines are cut by transversal, then alternate interior angles are congruent. If you look at this diagram, you see the left and right sides are congruent, and then GD would be a transversal. And these two angles that I got marked off here, those are alternate interior angles. And so if these two parallel lines are cut by that transversal, then alternate interior angles are congruent. That's what we have here. Okay. Now look at our third statement. So segment GD is congruent to segment GD. Let's mark that off. Segment GD, that's that segment there, is congruent to itself by reflexive property. All right, so we see that in the reason. Okay. So now we have all that marked off in our diagram. Now, what's our next step? We're saying those two triangles are congruent by SAS. Let's see if that's really true. So is the blue triangle congruent to the yellow triangle by side angle side? Well, look, you got in the blue triangle, you got side, included angle, side. Same thing in the yellow triangle, side, included angle, side. So if you took this yellow triangle and kind of rotated it counterclockwise, those two colored triangles would fall right on top of each other. So they're congruent by SAS. That's our fourth statement. Okay, now what we can say is angle EDG is congruent to angle FGD. Okay, so now we're going to be able to claim that these two angles, which are marked with a double arc, angle EDG is congruent to this angle DGF or FGD. It doesn't matter, it's the same angle. So those two angles are congruent because of our new reason here. Corresponding parts of congruent triangles are congruent. So we know those two angles are congruent. The ones I'd marked doubly with double arcs, those are congruent by Cpctc. Because once we know those two triangles are congruent, then we know that all their pairs of corresponding parts are congruent. Okay, now remember what we're trying to prove. We're trying to prove this top side here parallel to that bottom side. So ED, we're trying to prove parallel to GF. Okay, what comes next in our proof? Now we're going to state that they are parallel. Well, remember, that's a statement that you're trying to prove. Why are they parallel? Here's an old theorem. Remember, you can never forget your theorems. If two lines are cut by transversal and alternate interior angles are congruent, then the lines are parallel. Let's look at the drawing for that. Now we're saying that this top side, ED, is parallel to this bottom segment, GF, because if two lines, those two lines we're talking about, are cut by the transversal there is DG, and alternate interior angles are congruent. That's what we got from Cpctc. If all those conditions are met, then those lines are parallel. So that tells us that now the top and bottom parallel. So we were given the left side and right sides are parallel. Then we prove those two triangles congruent. And now we can say the top and bottom are parallel. And so there's your statements. So that's it for the. There's really no new theorem here. I mean, Cpctc, which is the title, is not a theorem. It's really a reason in a proof. And so the time that you use it is when you say want to prove a couple angles congruent, a couple sides congruent, or a couple lines parallel. You use this as a strategy when you prove two triangles congruent. And then once you know these two triangles are congruent, then you know that all their corresponding angles are congruent and all their corresponding sides are congruent. And so a step in your proof would be that two triangles are congruent. And then usually the following step would be these angles are congruent or these sides are congruent because of Cpctc, corresponding parts of congruent triangles are congruent. Okay, so the lesson that goes along with this topic is all proofs, all two-column proofs. And so you're going to have to kind of think about what's given, what you're trying to prove, and maybe lay out a plan before you dive into it and waste a bunch of time to if you don't know where you're going with it. So come up with a plan. At least try the proofs, get a feel for them, and if you can't carry them all the way out, definitely ask about them. But don't look at a proof and just say, "Well, I can't do that." Give up. You got to actually take a look at it and see if you can figure out what's going on. Okay, that's it for this video, and let's good luck, and let's try some proofs.